It's like AP Euro.
Oh, I thought it was.
This class up is together every single day before I Oh my God!
Just be happy you can use your volume buttons.
Okay, guys. So let's talk about the questions you had on this. Good news is we're going to be doing the same, almost the same exact thing today, just kind of adding some more, maybe a little bit more difficulty to it. I know this is not easy for you guys. We'll hopefully make sense of things a little. Again, I think the more practice you do with these, the better off they go. So one of the things on this one, we're going to do the matching. I was helping, like the top matching was pretty easy. I think most of you guys were like, that totally makes sense. It was probably almost on your chart. However, down here you had to do a little bit of simplifying, and you might have simplified on this side, but then also maybe needed to simplify it like a little bit on this side too. So, so the questions were about A and D here, unless people want to add any other ones. But so for A, I think you can simplify A a little bit. So this is a negative tangent. Now, I was talking earlier, I think I was talking with Becca about this. So tangent is on your sheet a couple of times. It talks about the tangent being 1 over cotangent, but the tangent is also sine over cosine. And we want to be strategic about which one we choose to use. So since I see a cosine already in the other part of the problem, I want to like involve that. So it's kind of like I want them to be alike. So if I can use that, I'm going to. So I'm going to switch tangent to sine over cosine. And then cosine is just cosine over 1. And so the cosines get to cancel. And so then we have negative sine of x. Is negative sine of x on your sheet anywhere? Yeah, it equals the sine of negative x. So this goes with green. So these two are the same then. So kind of just trying to make some of those connections there. Then looking at letter D, hopefully you notice that that one is not exactly a Pythagorean identity. It has some similarities, but it's not exactly that. Because if it was 1 minus sine squared of x, it'd be cosine squared, but it's not saying that. So, I'd almost need to do like cross elimination for some of the other ones, I think. I'm going to kind of, is that okay if I just go down the list? Some of you guys might want some of those anyway, I don't know. So I'm going to switch, I'm going to go to some of the other ones just to kind of eliminate and hopefully then figure it out. So secant squared minus 1, that's one of our rules that we know this is tangent squared. Now, tangent squared isn't over there, but I know sine squared over cosine squared is tangent squared. So this one should go with 1. So I've got that one taken care of. So again, I'm trying to do cross elimination maybe to get down to D. Now, secant over cosecant. Anytime I'm kind of stuck, it's a lot of times it's a good chance to try and use sine and cosine. So this is 1 over cosine, and then this is 1 over sine. So I multiply by the reciprocal. So this is 1 over cosine times sine over 1. Should be a 1 on the bottom. And then sine over cosine is just tangent, so this gets us down to 5 there. Now I know that number 2 and e should go together because those two are the same. So that tells me this one should go with 4, but that wouldn't have occurred to me right away. So I'm going to try and show you guys how we know that. So I'm going to try and simplify this to make it look this way. This is actually what we're going to be doing tomorrow, is they're going to give you the other side of the equal sign and you're going to have to make a match. So in this case, the cosecant is 1 over sine squared. Cotangent, again, I'm going to switch it over to cosine sine because of the fact that I know I don't want to bring another trig function in here. So I made these into a bunch of fractions. Now these two are like terms. Common denominators. So I can just add the tops. Now 1 minus cosine squared on our sheet, we know that that's sine squared. These cancel to just be 1. So I don't really know how it would have gone from here to here, but to go the other way makes a lot more sense. So being able to kind of manipulate that and fix that side to make sure it matches, or maybe you just did process elimination and like I did and figured out that was all that was left, but they should, they should connect. Okay? So flip to the back side, number 4 and 5. Now, in the directions, it does say use sines and cosines, so trying to head towards sines and cosines is probably a good idea. So what I did here was I figured out cotangent was cosine squared over sine squared, or cosine theta. Now make sure you do keep it as squared. I know some of you guys asked about that. So we're going to distribute that in. Now when I distribute it in here, hopefully you notice these all just cancel. So this is just going to equal 1. Now cosine squared over sine squared we know is cotangent squared. So we kind of got back to where we started from here. And I just realized something. I'll explain it in a second. So cotangent squared plus 1 on your, that's exactly what's on your Pythagorean identity. So that's secant squared, or cosecant squared, which should be theta. Now, I went this way about it. You might have noticed, if you just distributed it the way it was, the cotangent and tangent would cancel because they're reciprocals of each other. So if you didn't switch it over, you would have saved yourself some time. But, oh no, this should be secant. No, yeah, it is cosecant, sorry. So just trying different things, like again, that might not be the fastest way, but it worked. Now this next one, hopefully you noticed, this is conjugates. Anytime I see conjugates, it almost always tells me that I want a FOIL, like I should think FOIL as soon as I see a conjugate. So first, outer, inner, last. What the good news is, since they're conjugates, they're always going to cancel those middle terms out. Now, if you don't need to write those middle terms, like if you know that already, that's fine. So I have secant squared minus 1, if you look at that manipulation of the Pythagorean identity, the second one, that's just tangent squared. And you can just leave it this way. If you followed the directions and wanted it to be written with sine or cosine, you could write that as sine squared over cosine squared, but I'm fine. I think one trig function is better than like 2 if they're sine and cosine. All right. And again, just try some things, you guys. So like, just know that I did go through all, like I printed out a homework worksheet and I went through it all. And there was 2 I automatically just threw out. They were tougher than I would give you on the test, so I took them off of there. I don't want to like, I'm not doing things that I don't think you guys can you're like incapable of doing. I think you guys can do what I'm giving you. Just need to practice it. So, and there's gonna be some where you're gonna be like, I just can't get this one on this time. But maybe go back and look at it 2 days from now and try it again, or make yourself like cover it up and try like just making yourself like do a step at a time and kind of covering up part of it. Kind of like when you learn proofs as a geometry student. It's just new to you. It's something you've never seen before. So I will get you guys our notes for today. Our first question I think is a good review, a kind of warm up. So you want to do that first.
They're out of the system.